All right, it says it's live, so we'll go with it. All right, welcome in. Happy Tuesday. I hope everyone's doing well. I'm going to be hosting a live stream for the next probably at least 30 minutes. So if anyone has any questions about their math, maybe I can help. You're welcome to post in the chat and come and join me for math at this time. So try to keep my schedule consistent just so that viewers know what to expect. And yeah, just trying to open up my space and my time for a little bit to work on the math. So yeah, what I'm doing right now is I'm continuing this problem from yesterday and just kind of reflecting each day on my presenting methods and trying to refine my skills in writing on my board and talking about the math. And so basically from yesterday, I realized that I didn't do a really good job of explaining. So we're going to try it again and yeah, just informally hanging out and doing some math. Anyway, so I am working on systems of linear equations, and I'm using this system right here where we used last week. I solved it finding the inverse, and what I'm doing this time is a very similar method. However, I'm using a different method of finding the inverse. We're using this method called Gauss-Jordan Elimination. And honestly, I don't know if I'm pronouncing Gauss correctly or not. It could be Gauss. So I probably need to look at that. But what we're doing essentially is we took the matrix of coefficients and we augmented it with the identity matrix. And the identity matrix is found by putting a matrix in what's called reduced echelon form. And we put it in reduced echelon form by performing these steps they're called elementary row operations. So just trying to relearn the math and yeah, playing around with it. I used to be really good at these, and yesterday was kind of a wake-up call because sometimes I don't even realize what I've forgotten until I get in the throes of it. So I'm confidently going and thinking I know, and then it's like I go to do it and I'm like, oh, I'm not sure. And it's what it is, it's because I'm out of practice. So that's what this is about. So yeah, what I'm going to do is I actually spent some time in my spare time this morning and I found the solution. So I did it in 9 steps. So what I did was I kept track of the scalars, but I didn't keep track of what rows were getting added where. So I think what we'll do is we'll just put, let's see, 1, 2, I think I can fit them on this board. So we'll just go through the different steps because I was really happy that I found it. Like I said, these are kind of challenging for me, especially since I haven't been doing them. I've not been focusing on linear algebra and matrices. So yeah, we'll go ahead and erase most of this. I'm going to keep that system up and I'm going to go through the process again. And hopefully it'll be smoother this time because I actually did the work. I did my homework. Right. Hopefully I'll set a trend and I'll do that more often. I know that these live streams would probably go a little bit smoother if I was presenting something that I had a pretty solid practice on. So I feel like my grasp is pretty firm, but I obviously need practice, so. Okay, Right, start off with a clean board, erase almost everything. The very first thing I did was I augmented it with the identity matrix, and the identity matrix is found by following a set of rules, and I'll go through the rules real quick because I thought those were interesting. And we're just trying to pause and take it easy. Not really too worried about it. Up here, just hanging out, trying to not put pressure on myself in any way. I'm pretending like I have a room full of students rather than a camera, which is kind of hard to do. And let's see, Gauss-Jordan Elimination. So it's not the only application of Gauss-Jordan Elimination. You can actually augment the matrix with the constants matrix and proceed that way also. But this is another application. This is using Gauss-Jordan Elimination technically to find the inverse. And then we're just going to solve it by multiplying it by the coefficient matrix, which is perfectly acceptable. And I thought I had the steps. Let's see. I had them, and then I guess I should have just marked it. And part of this is me just reinforcing the knowledge in my own head, but then also there's probably students out there that are interested in this kind of thing. I remember doing a little bit of this when I was in high school, and it was really, I enjoyed doing it. All right, I'm gonna go with the old-fashioned method. All right, so we're not doing Gauss-Jordan elimination. We're just doing, okay, here, I found it. I love these definitions. Anyway, it says, a matrix is in reduced echelon form if any rows consisting entirely of zeros are grouped at the bottom of the matrix. It says, number 2, the first non-zero element of each row of each other row is a 1. This element is called a leading 1. 3, the leading 1 of each row after the first is positioned to the right of the leading 1 of the previous row. All other elements in a column that contain a leading 1 are 0. So it's in reduced echelon form, and it specifically referring to the identity matrix, but there can be other systems. And reduced echelon form is the process that we're seeking when we're solving. And if you were just doing the Gauss-Jordan elimination. So we're not doing that. What we're doing is we are using Gauss-Jordan to find the inverse of the matrix. Very similar to what we did last week, except for slightly different. Okay, so, all right, we'll go ahead and start by augmenting this matrix and listing out my coefficients. -3, -6, -15, 2, 3, 9, -4, -7, -17. In here, and then we're going to just attach the identity matrix on for a 3x3. So the first row is going to be 1, 0, 0. Second row is going to be 0, 1, 0. And then the third row is going to be 0, 0, 1. And you can just see the perfect diagonal of 1s, then we know we did it correctly. All right, so on my paper, it's showing the very first step, and I need my scratch paper that I did yesterday. Well, this morning. All right, so this is the first thing I did was I multiplied row 2 by 2. I wish I would have kept track of which rows got added, so I'll just have to figure that out. I think I added. All right, let's just try it, see what happens. So everything else is going to get written down exactly the way it is. We got -3, -6, -15, 1, 0, 0. 2 is row 2 is getting multiplied by the scalar 2, so we're going to get 4, 6, 18. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. Perfect. And then we have -4, -7, -17. It looks like I added row 2, so we'll write that down. So we're going to add row 2 to row 3, and we're going to replace row 3. So let's do that. So we've got 4 minus 4 is 0. 6 minus 7 is -1. 18 minus 17 is 1. 0 plus 0 is 0. 2 plus 0 is 2. And 0 plus 1 is 1. And then I just want to double check my work to make sure I did it correctly. 0, -1, 1, 0, 2, 1. Perfect. So let's go ahead and write in a new step. And it looks like this time I multiplied the third row by 6. That's what I did next. And then let's see if I can figure out what I did real quick. So we multiplied it by 6. And mind you, you can do multiple steps in a row and like at the same time. It's just that doing mental math in the evening time in front of camera, I feel like that's stressful enough for me. So I'm just trying to chill out and hang out and try to just have some fun. All right, so we're going to go ahead and repeat these 2 rows. Is that what I did? Yeah. So we got -3, -6, -15, 1, 0, 0. 4, 6, 18, 0, 2, 0. I think that the hardest part for me for solving these is just being careful. I am so clumsy and capable of making a mistake at any turn. So 6 times 0 is 0. 6 times -1 is -6. 6 times 1 is 6. 6 times 0 is 0. 6 times 2 is 12. 6 times 1 is 6. So any minor arithmetic error at all will throw the whole thing off and you'll get it wrong. So we just have to be really careful. All right. So in this step, I'm pretty sure that I added row 2 and row 3. But now I'm seeing that I could have done row 1 and 2. Again, I'm trying to solve it in as few steps as possible. However, there is no guarantee that I have found the least amount of steps. And we usually just get bored of a problem and move on, but trying to come up a level. All right, so it looks like I just rewrote it. Did I not add anything? So we got, oh, we did. We added row 2 We missed a step somewhere. Okay, so we added row 1 and row 2. So we have to add these 2 rows now. Okay. So we'll just say row 1 plus row 2. This one, let's go ahead and write these in here. All right. Okay, so I skipped a step, so I'm going to go back. This one is fun. We're going to add row 1 and 2 and see what happens. If I mess up too much, then I won't have room to fit it on my board, and that will be tragic. All right, so let's go ahead and just add these here. 4 plus -3 is 1. 6 minus 6 is 0. And I did replace row 1, just making sure. All right, 18 minus 15 is 3. 0 plus 1 is 1. 2 plus 0 is 2. And 0 plus 0 is 0. Perfect. We got 1, 0, 3, 1, 2, 0. Okay. And then it looks like we can just repeat these back here. Let's just put these in here. So that's 4, 6, 18, 0, 2, 0. And then I'm just going to go ahead and write this one in here. 0, -6, 6, 0, 12, and 6. And then hopefully I'm back where I was. Okay. So now what we're going to do is I think what I did here, I wish I would have taken better notes. I added row 2 and 3, and I replaced row 2. That's what I did. I added row, so we're going to do that. We're going to add row 2 plus row 3, and we'll replace row 3. Okay. Did I just say row 2 or 3? I replaced row 2, not row 3, so let's not mess that up. All right, hopefully I'm setting a good example though for students that you can be as imperfect as me and still be successful with math. It's not about being perfect. It's not about not making, or it's a lot of negatives. It's not about being perfect. That's not the point. The point is that you just never give up. You develop a resolve and you get determined to do something and then brute force it. All right, so that's pretty much how it works. So what did I do? -3, -6, -15, 1, 0, 0. We're going to add these 2 rows and we're replacing row 2. So 4 plus 0 is 4. 6 minus 6 is 0. 18 and 6 is 24. 0, 0 is 0. 2 plus 12 is 14. And 6 plus 0 is 6. And then we'll just write that row 3. 0, -6, 6, 0, 12, 6. All right. And then we'll really be careful and keep all the signs and keep all the rows and columns lined up. Okay. The next thing I did was I decided to multiply row 1 I've multiplied it by -4. Wait a second. I did another step in here somewhere. Okay, so we got I'm pretty sure I went this direction. What did I do? Okay, 1, 2, 3. How did I end up with this one again? I copied here. I was supposed to copy here. So I wrote this one wrong. I'm not pulling this one. I already replaced row 1. Okay, so it's up here, this one. Okay, let's see. I'll have to rewatch this. I am not good at following a script. Anybody that knows me knows that I'm not able to do that. I wouldn't be able to. So let's go ahead and write this row. This is the one I need. Oh, that scared me for a second because I thought that I messed everything up. 1, 2, 0. And really, I was ecstatic that I'd actually done it in so few steps. Like this morning, where I'm personally better at doing math in the morning than I am in the evening, but sometimes we don't have that luxury. So now I have to multiply this one by a -4. All right, so, and then I'm going to add it to row 2, and it looks like let me just double check these. I got 1, so make sure I'm on track. I've got 1, 0, 3. 1, 2, 0, 4, 6, 18, 0, 2, 0. It's this one. I multiplied by 4, so it's going to be 1, 0, 3, 2, 1, 2, 0, 4, 0, 24, 0, 14, 6. Okay, so here I am, -4. I'm going to multiply row 1 by -4. This is not as easy as I thought it would be. But I feel like the more you do something, the easier it does get. All right, so -4 times 1 is -4. -4 times 0 is 0. -4 times 3 is -12. -4 times 1 is -4. -4 times 2 is -8. -4 times 0 is 0. Okay, got that one. So it looks like I'm going to multiply how did I get 12 there? I did something to get 12. Let me just think about it. All right, looks like I got to add. I'm going to add row 1 and 2. All right, that's what we did. And then did we replace row 2? All right, looks like we replaced row 2. Let's try that. Maybe I should have just tried it again. So each time I do a live stream and I reflect back on my work, I think of something to do differently that would be better. So let's go ahead and see if we can do it in one step. What we're doing is we're adding row 1 after it's been multiplied by a scalar to row 2, and we're replacing row 2. So we've got -4 plus 4 is 0. 0 plus 0 is 0. 24 plus a negative 12 is positive 12. And then negative 4 plus 0 is negative 4. Negative 8 plus 14 is positive 6. And 6 plus 0 is 6. All right, and I'm just trying to be very careful because I don't want to mess anything up. I want to show how you get the matrix. And hopefully it doesn't take too long. That would be a bonus. So it looks like I'm going to multiply row 3. So it's 2 times row 3. Now we're going to say, let's see, what are we going to do with it? And I promise that I'll take better notes next time. And Allison time saves 9. I'm learning that the hard way. All right. And so I multiply row 3 by 2. And so we'll go ahead and do that. So 0. We'll just do it there. It's fine. 2 times 0 is 0. 2 times a negative 6 is negative 12. 2 times 6 is positive 12. 2 times 0 is 0. 2 times 12 is 24. 2 times 6 is 12. And I just want to double check the numbers to make sure. It's 0, negative 12, 12, 0, 24, 12. Looks like I got it. Okay, this one, negative 4, 0, 12, negative 4, negative 8, 0, 12, negative 4, 6, 6, 0. Okay, so it looks like the next step I did was I multiplied row 2 by negative 1. Row 2 got multiplied by negative 1. And I'll figure out what I did with that next. Row 2. So that's negative 1. That one's the same. Okay. 4, 0, negative 12, negative 4, negative 8, 0. Negative 1 times 0 is just 0. Negative 1 times 12 is negative 12. We've got positive 4. That's going to be a negative 6, negative 6. All right, and then did I add it to row 3 yet? I'm just going to see if I can just remember it, because going back to my notes is bothering me. It's too much. I feel like it's too hard. And 12. Okay. So it looks like if I just do a little bit of brain work, I should be able to figure it out. If I put, I'm going to add these 2 rows, obviously, and then I'm going to replace row 3, because I think that my logic was that I don't want to, like, once you have a 0 in place, you want to just keep that 0 there. So we're going to add, just say, row 2 plus row 3. And we'll mess that up. Let's see if we can fit it in here. I'm trying to write smaller so that I put all the steps in here. So negative 4, 0, negative 12, negative 4, negative 8, and 0. We're going to go ahead and write row 2 in here because we're not going to change it. So, not right now at least. 6, -6. But in this step, I want to go ahead and add these two rows and replace row 3. So 0 plus 0 is 0. 0 plus -12 is -12. 12 minus 12 is 0. 4 plus 0 is 4. 6 minus or 24 plus a -6 is going to be positive 18. 12 minus 6 is 6. All right. Now, what can we do? Did we do a -1 again? Somehow I missed a step somewhere, I think. Okay, we added those together. All right, so I'm going to go ahead and backtrack a little bit. I'm going to multiply. Okay, so I need this right here to be 0. So I think if I replace row 1, that's how I'm going to have to do it. So I obviously need practice. So let's multiply the second row by -1 again. Let's do that one more time. And then we're going to add it to row 1. So I'm going to not write row 1. I'll write the new row 2. These are both 0. That's going to become a positive 12. That'll become -4, positive 6, positive 6. Okay. And then we'll go ahead and write row 3, -12, 0, 4, 18, and 6. And then I'm going to add this row with the first row, second row, first row. So that's -4, 0. 0 plus 0 is 0. 12 plus -12 is 0. -4 minus 4 is -8. All right, let's see. This. What's this? So I'm going to write this in here. We're adding row 1 plus row 2. So row 1 and row 2, -4, 6 and -8 is -2. And then 6 and 0 is 6. All right. Let's see if I'm there. All right, I think the only other thing I have to do is I have to switch the order of the rows. Let me make sure I have these coefficients correct. -4, 0, 0, 8, 2, 6, 0, 0, 12, 4, and then 4, 18, and 6. All right, I think we're good. So we want the identity matrix. So what we have to do is we have to switch out. So we're going to swap. So we'll swap row 2 and 3. Okay, so let's do that. I'm clicking this step. We got -4, 0, 0, -8, -2, 6. And then instead of row 2, I'll write row 3. 0, -12, 0, 4, 18, and 6. And then we've got 0, 0, 12, -4, 6, 6. All right, so now all we have to do is we're going to multiply each one of these rows by scalar. This one's going to get multiplied by 1 over -4. Now I'm using reciprocals to figure out what I need to make that position a 1. And so you always just find the reciprocal, because a number and its reciprocal, the product is always equal to 1. So this one is going to get multiplied by the scalar 1 over -12. And then this one will get multiplied by the scalar 1 over 12, essentially. And then we'll have to figure out that math. So we know that this product is 1. So we'll go ahead and do that here. So we'll say -1/4 times the -4 is 1. 1/4 times 0 is 0. And then we got to figure out what -1/4 times -8 is. Let's do that off to the side here. So we have -8 times -1/4. That is going to equal +8 over 4, which is 2. And then we've got -1/4 times -2. Well, that's going to equal +2 over 4, which will reduce down to 1/2. And we've got -1/4 times 6. 6 times -1/4. So that's going to be -6 over 4, which is going to reduce down to -3/2. And we're just going to repeat that process with the other 2 rows. So this position will be 0. Anything multiplied by 0 is 0. This is going to be 1 because that's why we did that. We used the reciprocal. And then we got 0. And then -1/12 times 4. And that equals -4 over 12. And that is going to reduce down, let's see, 4 is 1/3, -1/3. And then -12 times 18. So that's going to be -18 over 12. And let's see, we've got 9 times 2 over, that's 6 times 2. And reduce it down one more time, 3 times 3 over 3 times 2. So we got 3/2 here. And it's negative, so let's not drop that negative. And we got 1 over -12 times 6. And that's going to reduce down to -1/2, because half of 12 is 6. All right. And then this one, same thing. Multiply by 0, you're going to get 0. Multiply by the reciprocal, you're going to get a product of 1. And then we've got to figure out, we already calculated 1/12 times -4. We'll just do it again, it's fine. Let's see, -4 times +1/12 now is going to be -4 over 12, which is 1/3, -1/3. And then we've got -3. Let's see, what are we doing? Half of 12, so this is just 1/2. 6 times 1/12 is 6. 6 times 1/12. I got distracted for a second. 6 divided by 12, that is 1/2. Because half of 12 is 6. And it's the same number, so we got 2 of them. All right, so we are almost finished. We essentially have found the inverse. So this is the inverse of our matrix here. And I did find it using a calculator. Now all we have to do is, let me see, let me make sure, because I have it written down here. So we've got 2 1/2, negative 3 halves, negative 1/3, negative 3 halves, negative 1/2, negative 1/3, 1/2. Perfect. Okay, mission accomplished. So as soon as you have, and I'm going to erase my scratch because I need this room. But as soon as you have your inverse, all you have to do is multiply by your constants. And we're going to form a matrix, and we'll just do that. We'll perform that matrix multiplication. Let me see if I can just skip this a little bit. I just chopped that off, didn't I? That's -1. Okay, it's okay. We don't need that anymore. So what I'm going to do is I'm going to put my inverse here. So it's 2 1/2, negative 3 halves, negative 1/3, negative 3 halves, negative 1/2. And this one is negative 1/3, 1/2, and 1/2. What I'm going to do is I'm going to multiply it by a constant, the constants matrix. So this is -3, 1, -4, and this should give solution. So it's this row times this column. And again, we're using that dot product. We got 2 times -3 is -6. 2 times of 1/2 is 1/2. And 2 times, sorry, negative 3 halves times -4 is a positive 12/2, which is 6. So this is just going to be 1/2. That first position. And we'll do this row times this column. So that's a negative 1/3 times -3, and that's making me positive 1. And we got a negative 3 halves times 1, that's a negative 3 halves. And then negative 1/2 times -4 is a positive 2. It's a positive 2. So we have 3 minus 3 halves, it looks like. Let's see, 3 minus 3 over 2. We'll change 3 into an improper fraction. That's 6/2. And so that's going to give me a positive 3 halves. And then we've got one more. It's this row times this column. So this is going to be negative 1/3 times -3, and it's going to be a positive 1 because it's reciprocal. So negative 1/3 times -3 is 1. 1/2 times 1 is 1/2. And 1/2 times -4 is -2. Okay, so -2 plus 1 is -1. So I have 1/2 minus 1. So that's 1/2 minus 2/2. So that's a -1/2. Perfect. So then you would just write the resulting, you would say x, y, z equal, you'd say 1/2, 3/2, and -1/2. And this is Okay, we did it. All right. Good. 45 minutes of math. That was a good little mental workout. Mission accomplished. It's always nice to have success, but I mean, to be honest, I feel like that. I mean, yes, it is exciting to be successful, but you know, I have to celebrate the small wins, and yeah, and I know that's not the point. The point is here in this space, it helps students. So hopefully I help someone. And I'm going to go ahead and sign off for now. And I'll say thank you for watching my video, and tune in tomorrow, same time, same place, and I will have something else to present. And yeah, so we'll just say bye for now, and I will see you next time. Bye.